First identified in 1967 following lab-associated outbreaks in Germany and Yugoslavia, this rare but highly fatal viral illness has seen the deaths of 900 people worldwide. Now, that number may seem relatively small in comparison to the widespread notoriety of its close relative Ebola, but with a case prevalence of only 1,100, Marburg virus disease carries a case fatality rate of over 80%. Of the orthomarburgvirus genus, Marburg virus is believed to be naturally found in rousettus aegyptiacus, or the Egyptian fruit bat. This is defined as a primary natural reservoir, or an environment in which a pathogen can be permanently maintained and further transferred to its target population. In this case, Marburg can be traced back to fruit bats that don't show signs of disease, meaning that these animals live with the virus within them and shed it into an environment that they inhabit. Now, this first case study happens in the Democratic Republic of the Congo. Between October of 1998 and September of 2000, a significant outbreak of MVD occurred in Durba and Watsa, northeastern DRC. A total of 154 cases were identified, of which 48 were lab confirmed and 106 were suspected. The overall case fatality rate was approximately 83%. Later implicated as the primary site of viral transmission, a majority of initial infections occurred in male gold miners working in the Garumba mine. Unfortunately, these miners were often subject to working deep underground in conditions that were poorly ventilated, unsanitary, and heavily contaminated with bat and human excrement. Of the 53 miners diagnosed with MVD, 94% had worked in this specific mine. So eventually, these outbreaks started to display a seasonal pattern, with October and February consistently seeing spikes in cases. It's also important to note that during this time, finding the host of Marburg virus was top priority. And after epidemiologic investigation, it was revealed that transmission was actually by multiple short independent chains with limited secondary spread. Now, that, coupled with the idea that 9 distinct Marburg virus lineages that were molecularly identified and also circulating during these outbreaks, it meant that the host had to be one in very large numbers, and one that was constantly reproducing or migrating. Basically, in the end, these outbreaks are what helped to identify the host of Marburg virus, years after its initial discovery in 1967. Quickly going back to the case study, transmission actually beyond the mines primarily occurred through caregiving. While only 20% of miners reported contact with other MVD cases, 67% of female patients were actually housewives and had contact with their MVD contracted partners. Now let's talk about Angola 2004. A second major outbreak has occurred in the Uige province, which will last until the March of 2005. During this period, 124 cases will be reported, 117 of which will be fatal, a case fatality rate of 94%. A majority of these cases, approximately 75%, happened in children under 5 years of age. A major theme of these outbreaks was actually limiting nosocomial transmission, or hospital-acquired infection, which they tried to do via education and raising awareness of the illness, and better infection control, better PPE. For the most part, this worked. A lot of nosocomial transmissions that increased fatality rates in previous outbreaks did seem to slow down during this one. Transmission of Marburg virus happens via direct contact with bodily fluids of infected individuals. It can even happen via contaminated surfaces and even during burial ceremonies involving the deceased. Nosocomial infections, like I said, have occurred through contaminated needles and inadequate protective measures, as documented in many of the early outbreaks. As mentioned on the WHO website, risk reduction initially focuses on reducing bat-to-human transmission, so I should mention minimize prolonged exposure to mines or caves inhabited by fruit bat colonies, and if working or visiting such a cave, wear gloves and other appropriate protective clothing. The reason I say this is because you won't know you've been exposed until after the 2 to 21 day incubation period for MVD. Your initial symptoms manifest as a severe headache, abrupt onset of high fever, malaise, and muscle aches. By day 3 to 5, you'll develop watery diarrhea, abdominal cramping, vomiting, and a maculopapular rash. Post day 5, hemorrhagic manifestations, bleeding from the nose, gums, GI tract, and IV sites. If severe, you'll die between day 8 and 9, preceded by shock and severe blood loss. Diagnosis of MVD requires highly secure lab testing under biosafety level 4 conditions, and due to difficulty in distinguishing from other infections such as malaria or typhoid, multiple confirmatory tests may need to be used or a non-inactivated sample may need to be transported internationally. Unfortunately, there are also no approved antiviral treatments or vaccines for Marburg virus. Treatment is primarily supportive and includes fluid resuscitation, electrolyte correction, and management of co-infections. Candidate monoclonal antibodies and vaccine platforms are under development, but haven't yet reached wide clinical use. This virus also has the ability to persist in immune-privileged sites, meaning an area of the body which provides a limited immune reaction if introduced to an antigen. For example, eyes, testes, placenta, and the central nervous system. The issue with this is that it raises concerns about long-term viral shedding and possible relapse. In conclusion, Marburg virus remains a high-consequence zoonosis with a history of explosive outbreaks around the world. Vigilance and outbreak preparedness, rapid public health response, and further research into vaccines and therapeutics are imperative to being prepared for future crises.